Welcome! In this series of videos, we will cover the design and implementation of a project, from initial design, through coding and development, to testing, using the PowerBasic Windows compiler. Today we will look to enhance a code library query utility, using the PowerBasic Windows compiler and the MLG custom grid. This was our application at the end of the last video. We have a dialog on screen which contains a toolbar and a My Little Grid. The grid can be populated by clicking on the toolbar button. Load Libraries. This gives us a folder browser, which when we select the Libraries folder and hit OK, it will populate the detail inside the grid of each function within each of the include files in that library folder. We're going to enhance our application slightly today and add a few more features. The first one to add is something we haven't covered in any of our videos so far, which is the ability to drag and drop objects onto the dialog. This will be using a couple of Windows API calls, but they're quite straightforward to use. So let's have a look at the code. If we have a look at the function which creates our dialog. In this function we have a dialog new command, and this gives details to the operating system for where we want the dialog appearing on screen and what options the dialog is to have. It then sends the handle of the dialog to this variable here, HDLG. What we're going to do after the PBForms end-dialog section is we're going to call a Windows API call called drag accept files. This will configure the dialog to allow it to accept files or folders being dropped upon it. This API call has only two parameters, the dialog handle and the value true. So we're setting the ability for this dialog to accept files to be true. Now that we've set that, we need to go to the event handler for the dialog, the callback function. In the callback function, there is a section for each of the events. We're going to add a new event here that we haven't used before. And this event is the WM drop files event. This will be triggered every time a file or folder has been dragged over the dialog. This event can handle the dragging and dropping of a single file or multiple files. In this case, we're only interested in dragging a folder, and we're only interested in the first folder. So we're going to use a Windows API call called drag query file. This Windows API call takes four parameters. The first parameter is cbwparam. That's the callback W parameter field. The next parameter, long I, is the item count of the file or files being dragged on to the dialog. We're going to leave long I valued at 0, as we're interested only in the very first item that's being dragged onto the dialog. The next parameter is the folder name. This is the path and the name of the object that's being dragged onto the dialog. And the very last parameter is using the PowerBasic sizeOf function to work out the size of the value held in folder name. We have used some variables here we have not yet declared, so we'll declare them at the top of the routine. We'll declare the folder name and long I. The str folder name we're defining as string Z. This is a fixed length string. We're setting this to be the maximum length of a path in Windows. Now that we have those set up, there's one more thing we have to do. We have to add the drag finish command with the parameter of cbwparam to tell our event that we have finished dragging files. Now that we have completed that, the str folder name now contains the name and path to our folder. Now a user could drag a single file onto this dialog, but we're only interested in folders within this application. So we can do a test to see whether the value passed is indeed a folder. So we're going to use the isFolder function, which is inbuilt to PowerBasic, to determine whether this folder actually exists. And only if the folder does exist are we going to perform our action. Since we already have a routine which populates the grid with the details of the library, we merely have to pass it the name of the folder. The load libraries function is expecting a string. However, str folder name is a string Z of fixed length. We can get around that by quite simply adding on a zero-len string to the end of our variable name. And when PowerBasic calls the underlying library, it will be passed as a string. And our second parameter is the grid handle. So if we try running our application now, our application will run as normal. We can still click on the load libraries to load a library by hand, but if we move this up to the corner and we open up the file manager, we can now attempt to drag our libraries folder over to the dialog. And simply dragging this library over will populate the grid quite happily. As you will now see, adding drag and drop facilities to your dialog is quite straightforward. And from a user's point of view, it's actually quicker than clicking on the Load Libraries button on the toolbar. If we attempt to copy a single file in, nothing will happen because a single file is not a folder. What we're going to do next is we want to put some search facilities into this application. So we're going to change the dialog slightly to make it slightly taller to allow room for a search field above the grid but below the toolbar. So we'll make the dialog slightly taller, we'll move the grid down slightly, and we will move the exit button down slightly as well. So that should have given us enough room to actually place a search field above the grid but below the toolbar. So we're now adding a few more controls to our dialog. A label to display the word search for, we'll set the colour of that to blue, a text box to allow the user to key some text in which we're going to be using to search the description column, and a search button. Also, I'm adding another label to allow us to display to the user how many matches have been found once they click the search button. I'm also updating the constants at the beginning of our application. So if we try running the application now, we'll see we now have the search for, a search box and a search button. There is no code underneath the search button yet, that's the next thing to do. But before we do that, we need somewhere to display the search results. We have a grid on screen at the moment which we're using to display all the details of what is in the libraries. We can quite easily add a second tab to our grid, a second sheet, to display results, as it's going to contain the same columns. So how can we do that in the code? If we have a look in the function where our dialog is created. Further down this function is the code that actually sets up the location and the configuration of our grid. At the bottom of this configuration section, we're going to add some new code on to add a second search sheet or tab. We can use one of the functions in our MyLittleGrid functions library to add a second sheet to our grid. It takes only two parameters, the grid handle and the text that you want on the search sheet itself. Now that the MyLittleGrid Light Utilities library has been going for a while, I've moved it into the main libraries folder. So I have already amended at the beginning of the code the call to where that library resides. So if we try running the code now, you'll now see on the grid we have a second tab called Search Results. Now I think we will rename the first tab to be something other than Demo Grid. In here where we named it, we'll change it from Demo Grid and we'll call this one Library now. So the library details will be on tab number 1 and the search details will be on tab number 2. As you will see on the search results, when we click on that, the size of the rows is unchanged. We will change the size of the rows once we've populated some data into that grid. So how do we do that? As we now have two tabs or sheets on the grid, there is some extra code we'll need to add in. In the event handler for the dialog, there are some changes we'll need to make. In the initialization handler section of the dialog, we put some code in to set the row height. And this was put in with a simple for next loop. Now there is a new function in our MyLittleGrid Lite library which will do that as a single line of code, calling a single function. So we will replace all of this code with one call to the new set row height for grid function. It takes of course two parameters, the grid handle and the height you want to set on the rows. We want to do the same logic for sheet number 2. In order to do that, we need to tell the MyLittleGrid which is a currently focused sheet. And we're going to use a macro called selectSheet, which exists in the MyLittleGrid Lite library. It takes two parameters, the grid handle and the sheet number. the search sheet is sheet number 2. We can then set the row height for that as well, and having set that to 50, we'll then mark the whole grid as read-only. This will stop the user making any changes to the data that appears in the grid. And having done that, we will reselect sheet number 1, and we'll mark that grid as read-only as well. So if we run the code now, so we will see if we select the Search Results tab, that the row height for its rows is exactly the same. So now we need to put some logic behind the search button to allow the user to key in something and then hit search. So if we look down to the WM command section where process control notifications arrive for button pushes, and we'll enter in an event to handle the button push on the search button, so that when that search button is clicked, we will perform our search. Using a control get text command will allow us to interrogate the data sitting in the text, and we'll move that to a variable called strText. If the value in strText, having been trimmed, is not a zero-line string, then the user must have keyed some data into it. And then to ensure that the currently selected sheet is indeed the first one, the first tab, we will use the select sheet command to set that up. And then we'll create a new function to perform our search. And we'll call that function run the search, taking 3 parameters: the handle of the dialog, the handle of the grid on the dialog, and the text the user has actually entered. So let's set up this new function to run the search. So here we are creating the new run the search function, setting up our 3 parameters: the dialog handle, the grid handle, and the text the user is searching for. What we're going to do here is we're going to create 2 arrays. One array which will contain the information that's currently on the library grid, and a second array to hold our results. We'll need to know how many rows are actually in the grid and how many columns. And we'll create a counter called longFound for the number of matches we actually find in the library. And then a simple row counter and column counter to allow us to write the found information to our search sheet, our search tab. We know we'll be searching the description column, and we'll set that in a variable as well. Now that we have those set up, let's determine the number of rows in the grid and the number of columns in the grid using the functions within our MyLittleGrid library. Having determined the number of rows and columns, we can now redimension our library array. And we're going to use the MyLittleGrid getX subroutine to extract the data that's in the currently focused grid, which is the first tab, the first sheet, and we're going to populate that data into the strlibdata array. And we will prepare our results grid to be the same size. As we want this search to be a case-independent search, we will use the uCase command to force the strText variable to uppercase. So everything is now ready for us to step through the data within our strlibdata array to look for this value. So this will be a for next loop. So for each row within this array, we're going to use the inString command to determine whether we've found a match or not. inString will return a value of either 0 to say nothing has been found, or a value greater than 0 to say that the string you're looking for has been found in this string. So we're looking for the row and the description column, which is column number 5. If we find a match, we can increment the longFound variable to count up the number of finds we've actually made. And since we have actually found a match, we want to copy all the data in the columns of the library grid into the results grid. So again, this is another for next loop. So our strResults array will be built up incrementally as we step through this for next loop for long row. Now that we've swept through this array and we've found all the matches we can find and added them to the strResults array, we can now look to put that information into the grid. As we know the results grid is tab number 2, we're going to use the select sheet command to select that sheet or tab as number 2. In case there's any information within that tab from a previous search, we'll now clear that grid out. We can now use the MLG putX command to put all the data that's within that array into our selected tab on the grid. So let's try running that code now and see how far we've got. If we drag our libraries folder, our data in the grid is populated. Now if we type some search information into our text box and hit the search button, we're getting some results coming back. We haven't colour banded the grid yet, which we'll do in a moment, but the other thing we can notice is the value in the description column is not word wrapped. So we need to add that piece of code as well. So once the data is in our grid, we need to do the word wrapping code. So another simple for next loop to look through each row in that grid tab. We're going to use the set format override command to make sure that that particular column, in this case the description column, is word wrapped. And following that, we can colour bank our grid rows and refresh the grid. Additionally, since we know how many matches have actually been found, we can update that field we put on the main dialog to let the user know how many matches have been discovered. We can use the control set text command to do that quite easily. So let's try running that code now. There is our grid. Let's copy in our libraries folder, which is now populated, and we will type in what we're searching for. And now we can see it's colour banded and the text in the description field is now word wrapped. So our data is being returned quite happily. The last fairly cosmetic thing we'll want to do is to make the search button the default button. So once the user has actually keyed the information they're searching for, they merely have to press return and it will do the search. If we have a look at the function where the dialog is specified, there'll be a line of code for control add button for our search button. If that search button has this property actually set, then it will default to being the default push button. So having done that, if we run our code now, bring our library in, type in what we're looking for, and press the enter button, it will search quite happily, saving the user having to move the mouse. And it's correctly telling us it's found 14 matches. So anything you need to look for, you merely have to put the text in now. Hit the enter button and the number of matches will be brought up. So it should be easier to actually find libraries. The very last piece of code I'm going to put in today is a bit of code in the drop files event. In our drop files event at the moment, when we do the dragging and dropping, we're testing for the folder and we're attempting to load the libraries straight away. However, at that point in time, we want to ensure that the currently selected sheet is sheet number 1. So we can put some code in to ensure that actually happens. We will select sheet number 2 and we will clear that grid tab out complete. And then before we call the load libraries function, we'll select sheet number 1 to ensure that is the currently selected sheet and it will populate correctly. So we can do our first search. We can drag the same folder in again and it will correctly move to the first tab, which is the library tab, and the search results will be blank. So even if you're on the search results tab, it will still function properly. What we will do in our next video for this project is to allow you to drill down to actually see the data within a function, which will hopefully make this code library even more useful. But that's it for today. Thank you for watching.